We'll start with physics. See, whatever we are going to see in this class is kind of revision. We have all come across all these topics, okay, from childhood. We'll be revising everything efficiently as much as possible, okay? So physics is basically science of matter, motion, energy, and the interaction between them. So physics will have many physical quantities involved, okay, like distance, like time, like speed, like power, work, etc. It has so many physical quantities involved. And basically physical quantities has two types. As I go about it, take your own notes, okay? Two types. One is fundamental quantity, second is derived quantity. See, fundamental quantity, there are basically 7 fundamental quantity. As we list out, you can understand it better. Like length, mass. It is measured on its own. It doesn't depend on other physical quantities to quantify. It can be measured on its own. Okay, like length, like mass, like time. The 7 fundamental physical quantities we're seeing: electric current, temperature, luminous intensity, intensity of light, it is luminous intensity, and amount of substance, in chemistry, amount of small substances in large quantity, we'll measure it in mole, mole, length in meter, mass in kg, time in seconds, electric current in ampere, temperature in Kelvin, SI unit, and candela, it is candela. So these are the basic 7 fundamental quantities which can be measured, directly. And derived quantities uses these fundamental quantities, one or two or more even fundamental quantities which derive pannida derived quantities கண்டுபிடிக்க முடியும். See example, speed. Speed is distance by time. Two fundamental quantities are used to derive this physical quantity, which is speed. So this is derived quantity. I think you're all clear. Let us go into another such type. It is scalar and vector quantity. See, scalar quantity will have only magnitude. Magnitude na size. Only magnitude will be present in vector quantities. Okay. So, sorry, scalar quantities.
Scalar.
When it comes to, yeah, thank you. When it comes to vector, we'll have both. We'll have especially both magnitude, that is the size, as well as direction. So this is the difference between scalar and vector quantity. This is another distinction. See, only magnitude அப்படின்னா distance. Distance na nothing but length. இவ்வளோதான் distance. 1 kilometer, 2 kilometer, 30 meters. அதான் சொல்லுவேமே தவிர it doesn't give any information about any direction involved. Okay. Even time. It doesn't give time இவ்வளோ. Time இப்ப இது. இவ்வளோ time taken. So 3 hours taken, 4 hours taken. It talks only about time. It gives only the magnitude, but not the direction. Okay. Vector quantity like velocity, force. These things will give direction. Velocity அப்படினாலே ஒரு பார்ட்டிகளோட ஸ்பீட் மட்டும் இல்லாம அது என்ன டைரக்ஷன் அப்படிங்கறதையும் கன்வே பண்ணுவாங்க. ஸோ ஒரு ஆப்ஜெக்டோட வெலாசிட்டின்னு சொல்லும் போது இந்த டைரக்ஷன் ஈஸ்ட் ஸ்பீடோட சேர்த்து இந்த டைரக்ஷனையும் மென்ஷன் பண்ணுவாங்க. That is velocity. So this is vector quantity examples. Okay. We'll go into each of those. Okay. We'll start with mass. See, does any one of you know what is the difference between mass and weight? Just say in simple terms.
Mass is constant. Wherever we go, mass will remain constant, but weight will vary according to the gravity.
Yeah, very good. That is the only distinction between mass and weight. See, mass means he said no, wherever we go, mass வந்து change ஆகாதுன்னு சொல்லி it does not change அப்படிங்கிறதுக்கு அர்த்தம் என்னன்னா based on location. If we are here, we are in North Pole, we are somewhere else in another country, the location change ஆகுறனால mass will not change. Mass will change when we lose fat, we lose weight, in that case only mass will change. Based on location, it won't change. But weight and mass, the unit of mass is kilogram and the unit of weight is Newton. Okay. So mass na என்னன்னா ஒரு பாடியில எவ்வளோ amount of matter இருக்கு, that is mass. Okay. Definitionலாம் எழுதணும்னா எழுதிக்கோங்க, or else you can always Google it. But I want you all to understand what it is. Basically know what it is. So side by side, write down the definition and just listen to what the concept is basically about. So mass is the amount of matter in a body as such. இவ்ளோ kgs, இவ்ளோ grams, that is mass. But weight என்னன்னா ஒரு mass இருக்கு. இப்ப நம்மளோட mass வந்து இவ்ளோ kgs, 50 kgs அப்படி சொல்றோம் அப்படின்னா, weight அப்படிங்கிறது when we are in the earth or any planet which has certain gravity, it will be a downward pulling force acting on us. And it will, when a force is acting on us, there will be more, the mass will be more, no? That is weight. When gravity's force is acting on a mass, when the gravity's force gets added to a mass, that is weight. Okay. And the unit of it is Newton. This is clearly mass, which is weight. That is the only distinction. இது weight ஓட formula என்னன்னா, weight is mass multiplied by force of gravity. That is acceleration due to gravity. Acceleration due to gravity na ஒன்னும் இல்ல, gravity ஓட forceனால an object with mass is getting accelerated more. A pulling force. That is, so force of gravity basically. So when we multiply a mass with the force of gravity together, we'll get the weight. Okay. When you move out of here to the space, for example, space ku poningana, weight will be zero. We'll be weightless. You all would have heard weightlessness space அப்படி சொல்வாங்க. Why? Because there is no gravity acting on it and we couldn't feel the weight because there is no gravity. Okay. When this becomes zero, weight becomes zero. That is weightlessness in space. Okay. We'll go to velocity. Before velocity, we'll go into speed. Speed is basically distance by time. How much of distance is covered in unit time, or rate of change of distance, that is speed. You would have read in your numerical ability. Okay. So what is the difference between speed and velocity? Speed versus velocity. Can anyone say the difference? See, speed is nothing but the distance with respect to time. That is, எவ்வளோ குயிக்கா ஒரு ஆப்ஜெக்ட் மூவ் ஆகுது, அதுதான் ஸ்பீடு. ஸ்பீடோட வேர்டோட அர்த்தம் நமக்கு தெரியும். ஹவு குவிக்லி சம்திங் இஸ் மூவிங், தட் இஸ் ஸ்பீட். ஓகே. ஸோ வெலாசிட்டியில என்னன்னா, ஸ்பீட் இஸ் அ ஸ்கேலார் குவான்டிட்டி. எவ்வளோ ஸ்பீடு, அந்த ஸ்பீடோட யூனிட் மட்டும் தான் அதை சொல்லும். மீட்டர் பெர் செகண்ட் இஸ் த யூனிட் ஆஃப் ஸ்பீட். இவ்வளோ மீட்டர் பெர் செகண்ட் போயிருக்கு, 50 மீட்டர் பெர் செகண்ட். ஓகே. 50 மீட்டர் பெர் செகண்ட், 60 மீட்டர் பெர் செகண்ட், இதுதான் வந்து speed. But when it comes to velocity, it gives information about direction also. So velocity involves speed as well as direction. Vector quantity explain பண்ணும்போது சொன்னேன்ல, இது ஏன் வெக்டார் வெலாசிட்டி அப்படின்னா, ஸ்பீடுனா வெறும் ஸ்பீடு பத்தி பேசுவோம், வெலாசிட்டினா ஸ்பீட் as well as direction of an object. Rate of change of an object's position with respect to frame of reference and time. Basically the explanation is speed with respect to speed and direction of an object together put gives you velocity of an object. Simply put, இப்ப speed அப்படின்னா 50 meter per second மட்டும் தான் சொல்லுவோம். ஆனா velocity அப்படின்னா same meter per second தான் சொல்லுவோம். ஆனா we'll give information on direction, east, west, clockwise, anti-clockwise, some information about direction will be there. That is velocity and speed. Okay. Acceleration means, see, when velocity apdina, say a speed, or a speed increase, there is speed and it is moving in a particular direction. That is an object with velocity will do. Okay. When the speed increases or decreases, increase panna adu positive acceleration, decrease panna adu negative acceleration. Okay. Or else when there is change in direction, when there is change in speed, whether it increase, whether it decrease, or when there is change in direction, acceleration will come into play. Okay. So acceleration is nothing but it is rate of change of velocity. Acceleration is nothing but rate of change of velocity. Speed is nothing but rate of change of distance. So no, similarly, acceleration is nothing but rate of change of velocity. So what is momentum? Momentum ku idu oru formula podum. We already know what is velocity. See, the basic difference between velocity and momentum is this. Velocity will involve only the speed and direction, whereas in addition to the speed and direction, momentum will include mass of an object. Whenever an object with mass has some velocity, then we will say it has this momentum. It has this momentum. So momentum is mass multiplied by velocity. This is the formula. Take down this formula as well as put velocity versus momentum and write down these things. In addition to speed and direction contained in velocity, when mass gets multiplied, it is momentum. Okay. So we'll go into force. எல்லாருமே படிச்சிருப்போம் push or pull is called a force அப்படின்னு சொல்லி. Some push, force க்கு we are taking these words push or pull, or it can be anything, any external, any contact or non-contact force can be applied on something. Okay. For example, gravitation is a non-contact force. Pushing or pulling with something, pulling an object is a contact force. So there are so many different kinds of forces. So we use this to define it. So pushing or pulling an object and changing its velocity or changing its direction. There is a brick, you push it, you'll displace it to a certain distance. So some work will be done. So force will basically change a velocity or the speed, basically the velocity, that is speed. It will change the speed or it will change the direction. When force is applied, a change happens, that is force. And we'll go into motion in physics. When we say a particle or an object is in motion, we say it is in movement, it is moving, that is motion. So circular motion kulla polam. See, rectilinear motion, which is straight, an object moving in straight line, that is rectilinear. There is nothing to study more on that. We'll straightly go into circular motion. Okay. Does anybody here know what is centripetal force? Circular motion will involve two forces, centripetal and centrifugal force. Does anyone know?
Moving towards the center point of the circle.
See, okay. I'll explain it. Centripetal is towards center. Centripetal is towards center. A force which pushes an object or which keeps an object towards center. Okay. Centrifugal is away from center. See, we can take an example of moon revolving around Earth. In which direction moon will revolve? Clockwise or anti-clockwise? Please answer. Can you all hear me?
Yes, ma'am.
See, okay. The moon revolves in counterclockwise direction. It is not clockwise. So we'll take the example of moon here. I'm explaining centripetal force here. Okay. The moon will have its own mass. It will have its own mass and it will have its own velocity. So it will be having its own velocity and it will be revolving in this anti-clockwise direction. around the earth. Okay, but why we took this example is that it is having this circular path, almost circular path around earth. And whenever a circular motion or circular path is involved, these two forces are involved simply. And something is keeping this moon around this earth in circular motion. Okay, it is revolving around something, that is, which is the earth. Apdina towards center, it has some force pulling it. Okay, so there is centripetal force involved. So basically, a moon will have its own mass and its own velocity. Okay, and where take an example of a ball here. Okay, we'll go to the moon. Say it is moving in a straight direction, straight path, and it has a uniform velocity. Okay, in this direction. இப்போ ஒரு forcing apply பண்றோம். Now the ball is here. When in a moving ball, a force is applied, the ball will deviate its direction like this. இங்க force apply பண்ணோம்னா ball will move like this. Consider it has the same velocity and it is moving on like this. When it comes here, when you apply some force perpendicular to it, it will move and come here. And when you apply a force perpendicular to this direction, perpendicular force here, the ball will go like this. Okay, and again perpendicular force apply பண்ணிட்டே இருந்தீங்கன்னா it will have this almost circular path. And when you apply it ரொம்ப கம்மி time distanceலயே நீங்க apply பண்ணிட்டே இருந்தீங்கன்னா we'll have a circular path. So whenever an object is moving with a velocity in a straight path, and whenever a force is applied with short intervals of time, or when the force is very huge, it will curve its path, and that's how a circular path is attained. So when an object, say, come to this moon here, when an object with a mass and velocity moves, it will move only in a straight line until a perpendicular force is constantly acting on it. Okay, here this force is not external. இந்த பக்கத்துல இருந்து வரல. Earth's gravity is pulling it. So the constant pull of Earth's gravity will be the perpendicular force acting on the moon. And the moon has its own mass and velocity, will just curve its path and go around the Earth, towards the center, the force is getting applied. So the gravity இங்கிருந்து internal pull பண்ற force அது. Okay, so this is centripetal force. Centripetal force is gravity applied from here or some external force applied from here, anything. But when an object's path is curved by the perpendicular force acting on it, keeping it to the center, that is centripetal force. இதே மாதிரி ஒரு பால் கையில வச்சுட்டு ரொட்டேட் பண்ணிட்டே இருக்கோம் அப்படின்னா, for example, I'll give you another example. Car. When we drive in a car, we'll be when we take a sudden turn, okay, right turn, we'll be moving towards left. Am I right? So when you take left turn, you'll be moving towards right. When you apply sudden brake, you'll go front. Okay, so these kind of opposite எங்க turn பண்றீங்களோ, when you drive a car and you take a right turn, your body moves left. Okay, so basically what is happening is centripetal force is first of all happening. ஏன்னா கார்ல இருக்க டயர், காரோட வீல் வந்துட்டு நம்ம ஸ்டேரிங் வச்சு திருப்பும் போது centripetal force வந்து இங்க ஒரு சென்டர் எடுத்துக்கிட்டு it is getting turned. Okay, centripetal force தான் ஆக்ட் ஆகும். ஆனா நம்ம அந்த மோஷனுக்குள்ள, அந்த மூமெண்ட்குள்ள நம்ம பிரசன்ட் ஆயிடணும் அப்படின்னா we'll experience this opposite force on us. We'll move towards the left. That force is centrifugal force. So இங்கே பாத்தீங்கன்னா moon or a ball அப்படின்னு இமேஜின் பண்ணிக்கோங்க. If it is tied on a cloth, a shawl, இத மாதிரி இது inward நோக்கி revolve ஆயிட்டு இருக்கும்போது that cloth will be moving outwards. So whenever a centrifugal force is present and whenever an object is present in that frame of reference, இங்க centripetal force act பண்ணி inward pull பண்ணிட்டு இருக்கும்போது that object will experience an outward force. Okay, the force which we experience in the opposite direction when we make a turn, that is centrifugal force. Okay, I think it is clear now. We'll go into Newton's law of motion. And the first law of motion, can anyone explain what is the first law? First law is basically law of inertia. What is inertia? See, inertia word mattu ettutta. Inertia is lack of energy or inability to move, or even inability to move. Basically resistance to change, whether it is in static position without movement, an object, okay, whether it is in static position or whether it is moving with an velocity or speed, okay. So unless it is disturbed, unless this is given a speed or a force, or unless this is given a change of direction, it will not change its path automatically under any condition. That is inertia, law of inertia. Okay. An object at rest remains at rest. An object in motion remains in motion at constant speed and in a straight line unless acted by an unbalanced force. So basically, first law is law of inertia. Second law is nothing but force is equal to mass into acceleration. The acceleration of an object depends on mass of an object and amount of force applied on it. Just remember the formula. F is equal to ma for Newton's second law of motion. Okay. So, and third law, we are all familiar with, the principle behind jet propulsion in airplane. It is for every action, there is an equal and opposite reaction. That is Newton's third law. I want you all to do as a homework to, find out application, at least any 2 applications of each of these 3 laws. Make sure you do it. Okay. Coming on to frictional force. What is frictional force in simple words? What is friction? See, take an example of a slide.
Contact force, ma'am.
It is echoing actually. Can you come again? Say it again.
It is a contact force, ma'am.
Yes, it is a contact force. There are many contact forces. One of the contact force is frictional force. But frictional force na enna appadina actually force generated by 2 surfaces that contact and slide against each other. Simple example is a slide. Children playing slide in park. We'll just slide it. Okay. The point of contact between this person and the slide is the back of the person and the slide, the floor of the slide. Okay. And when they, எப்போ வந்து அவங்க ஸ்லைட்ல வராங்களோ, they'll have certain speed involved. And the speed is not ரொம்ப ஸ்பீடா வந்தா it is fatal. Okay. And the speed gets limited to balance because of the friction present between the point of contact, between the person and the slide. Since there is some friction, the speed is getting limited. Friction illa, very polished, and there is zero friction appadina, we cannot control the speed. Okay, that is friction. Friction depends on in the surface. Ipo slide in எடுத்துக்கிட்டோம்ல, any surface or any machine or anything, when 2 things are in contact with each other, moving against each other, friction will come into place. Okay. And it depends on 2 things. One is the texture. When it is a hard surface, friction will be more. When it is a very polished surface, friction will be less. Okay. It depends on the texture of the surface and also the force applied to it. That is all about friction. Okay. Come to work. Give me a minute. Yeah, we'll start with work. The work is again a scalar quantity. It does not provide you with direction. Okay. It has only magnitude. Basically, what work done is force acting on an object. When a force, say, imagine we are applying a force to a brick or an object. The force applied as well as the, we are taking a brick, okay. Force வந்து ஒரு brickல act பண்றோம். The force given on it and the displacement that has happened, it will move from here to here. So the displacement that has happened, force given and the consequence happen because of it. Together put, that is work. Work done na adudha. So work is basically force into the displacement that just happened. Just note down this formula and have it in mind. Just don't go through the definition each and every time. Okay. We'll go into power and we'll come to energy after that. Okay. See, power is rate of change of work done. That is, simply put, rate of doing work. How fast a work is done. The rate at which a work is done. That is power. Okay. Power is basically rate of work done. Okay. And the unit of power is joules per second. For work, it is joules. And for energy also, we use various units, also joules. See, energy is basically an ability to do work. Even in physics, it is the same. An ability to do this work. That is energy. And there is two kinds of energy, which is potential energy and kinetic energy. Can someone explain what is potential energy and kinetic energy? Simple words.
Kinetic energy is dynamic, ma'am. Potential energy is static.
Hammer வந்து கையில இருந்துட்டு ஓங்குவோம்ல மேல மேல அப்ப வந்து when we take the hammer out ready to hit it, when the hammer is above our head, at that particular point we say it has potential energy. Potential அப்படின்னா something it has to some potential சொல்லுவோம் we have some talent, that there is something to do out of something, with something, that is potential. So the hammer we have raised above our head, ready to that is potential energy. That hammer is said to have potential energy. Okay. And when it actually hammers down an object, கீழ வந்து hammer பண்ணுவோம்ல, when that particular action is done, that particular thing is said to be kinetic energy. Energy used, energy in motion, energy that has just been used. So this is the basic example that I could give for potential and kinetic energy. When something in a position wherein it has some potential energy that can be used to do something. அதோட placement இருக்கலாம், like hammer-ஓட placement position வந்து it is above the head, ready to be used, position or with respect to time, என்னவா வேணா இருக்கலாம். When it is static but it has that potential energy, that is potential energy. And when it is actually being used in motion, that is kinetic energy. Okay, we'll go into wave. We all know what is a wave. It is basically, we can say wave na enna definition மூலமா சொல்லணும்னா, it can be a disturbance. A wave can happen in any medium, air, water. Okay, so basically a disturbance, and also it by means of that disturbance or oscillation, it transfers energy. Okay, basically a wave will be like this. Okay, it basically transfers energy. Wave length அப்படி கொடுத்திருக்காங்கல்ல, lambda அப்படின்னு மீன் பண்ணுவாங்க. Wave length is this, two high points reach பண்றதுக்கு எவ்வளோ டைம் எடுத்துக்குதோ, எவ்வளோ distance எடுத்துக்குதோ, that is wavelength. And this is one oscillation. To this point of this wave, to this point of this wave, this is one oscillation. Okay. And number of oscillations per second, rate of change of oscillation per second, that is frequency. And amplitude is this distance between the wave. Okay. So we know what is frequency, we know what is oscillation, we know what is wavelength, we know what is amplitude. Okay. And we'll come to types of waves. Waves are of two types, basic mechanical wave and electromagnetic wave. See, electromagnetic wave will use, mechanical wave will need a medium. Medium அப்படின்னா air, water, a medium it requires. But electromagnetic waves does not require a medium. Even in vacuum, it can travel. And it basically travels by using electric and magnetic field. That's why it is electromagnetic wave. Okay. And first we'll go with mechanical wave. So mechanical wave na a wave which travels with the medium and not in vacuum, and it has two types. Mechanical wave is of two types. One is longitudinal, another one is transverse. See, ஒரு wave அப்படின்னு சொல்றோம்னா பேசிக்கா ஒரு ரியல் லைஃப் எக்ஸாம்பிள் மாதிரி திங்க் பண்ணீங்கன்னா it will involve certain particles in it and it will involve this wave by itself, okay, as an energy. And the energy transfer ஆகும்போது there will be particles also involved in it. Okay, see, transverse wave ஓட ஒரு good example is light wave. Longitudinal wave ஓட ஒரு example is sound wave. See, longitudinal wave அப்படின்னா particles and wave ரெண்டுமே parallel இருக்கும். particles ஓட வைப்ரேஷனும் லெஃப்ட் அண்ட் ரைட்ல தான் இருக்கும். இப்படிதான் முன்ன பின்னதான் பார்ட்டிகல்ஸோட வைப்ரேஷன்ஸும் இருக்கும், வேவோட மூவ்மெண்ட்டும் இந்த டைரக்ஷன்ல தான் இருக்கும். the particles vibration as well as the waves propagation will be in one direction. That is longitudinal wave, example sound wave. And transverse wave na the opposite thing. when a wave ஓட டைரக்ஷன் இதுதான், வேவ் டைரக்ஷன் இதுதான் அப்படின்னா பார்ட்டிகளோட டைரக்ஷன் அப் அண்ட் டவுன் இருக்கும், பெர்பெண்டிகுலர் இருக்கும். பார்ட்டிகல் டைரக்ஷன், particles vibration will be perpendicular to the wave's direction. Okay, it will be like this. There will be more wavelength and all. Example is light wave. This is light wave example. This is sound. So these are the types of mechanical waves. We'll go into electromagnetic, which is non-mechanical waves. There are these things, okay? Gamma rays, X-rays, UV rays, visible radiation, infrared rays, short radio waves, long radio waves. So these are the basic electromagnetic waves. See, gamma rays இந்த electromagnetic radiation spectrum கொடுத்திருக்காங்கல்ல, இதுல gamma rays will have the highest frequency and decreasing frequency ல எழுதிருக்காங்க, and long radio waves will have the lowest frequency. And also noted down, frequency and wavelength are inversely proportional. இங்க கொடுத்திருக்க ஆர்டர்ல அப்ப இங்க ஹையஸ்ட் frequency gamma raysக்குனா அப்ப lowest wavelengthக்கும் gamma raysக்கு தான் இருக்கும். And அது இன்க்ரீஸ் ஆகிக்கிட்டே வரும். highest wavelength long radio waves. இது உங்களுக்கு கொஸ்டினா எப்படி அரேஞ்ச் பண்ணுவாங்க அப்படின்னா lowest wavelength to highest wavelength and the list of electromagnetic waves you have to be thorough with. எதுக்கு highest frequency, எதுக்கு lowest frequency, and the order, if you know, you can answer it. Okay, we'll go into light. Just now we saw light is a wave. It is a form of energy. And it visible radiation அப்படின்னு கொடுத்திருக்காங்களே, it is nothing but visible light. Okay, it is an electromagnetic wave. It uses electric field and magnetic field in order to move. And light வந்து ஸ்பேஸ்ல கூட நம்மளுக்கு சன்ல இருந்து தானே எர்த்துக்கு வருது. It can travel in vacuum. So it is definitely an electromagnetic wave. And light is basically movement of a particle called photon. And it has a speed 3 into 10 power 8 meter per second. And it is a transverse wave, as we already saw. Can any one of you say why this phenomena happens? Only inside Earth we can see the color of sky is blue. Why it is so? Can anyone answer?
It is scattered by the atmospheric particles.
Yes, it is scattered by the atmospheric particle, and also search for visible light spectrum image வரும். உங்களுக்கு எந்த கலருக்கு எவ்வளோ wavelength இருக்கும். Blue has very shorter wavelength and red has very long wavelength. Okay. So அந்த blue particles தான் will have very shorter wavelength, and when it is scattered, and that phenomenon only is projecting, it is like the sky is blue. Okay. So make sure you go through the picture, Google it, and go through visible light spectrum.
மேம் அப்படின்னா வயலட் இண்டிகோ அதை விட கம்மியா தானே இருக்கும்.
See, the particles in the atmosphere, atmosphereல இருக்கிற particles வந்து எல்லா லைட்டையும் ஸ்கேட்டர் பண்ணும். when a light is coming inside the earth, atmosphereல நம்மளுக்கு particular particles இருக்கும். we have it. Okay, it is not changing. And when those particles are the only particles which can scatter all those light, and அது choose பண்ணி blue மட்டும் scatter பண்ணாது. it is going to scatter all those lights, but the blue's wavelength is very similar or near to the wavelength of those majority particles present in the atmosphere. So all those particles put together, when scattering that nearest wavelength light, we get to see blue. Okay. Say yes.
ஓகே மேம்.
Okay, we'll go into, as we come into the topic light, we'll go into laws of reflection. Okay. We'll go with this image. We'll take any medium. Here we are taking a mirror. Mirror is a perfect reflector. Okay. So A இங்க கொடுத்திருக்கிறது, it is incident light. ஒரு incident light rays pass பண்றோம் ஒரு image மேல at an angle, not in a straight line, at an angle place pass பண்றோம் அப்படின்னா reflect ஆகும். ஏன்னா mirror is a polished plain surface, so it will reflect it, and this is the reflection. ஒரு light rays வந்து ஒரு angle pass பண்றோம் ஒரு reflective surfaceல அப்படின்னா it will be reflected. And there is two incidents அப்படின்னா என்ன light rays pass பண்றோமோ அதை incidence angle சொல்லுவோம். எங்க போய் அது பாயிண்ட் ஆஃப் கான்டாக்ட் மேக் பண்ணுதோ அங்க இருந்து ஒரு பெர்பெண்டிகுலர் லைன் வரைகிறத நார்மல்னு சொல்லுவோம். கொஸ்டின்ல நார்மல் அப்படின்ற ஒரு லைன் யூஸ் பண்றாங்க. ரிஃப்ளெக்ஷன், லாஸ் ஆஃப் ரிஃப்ளெக்ஷன் பத்தி ஒரு கொஸ்டின், நார்மல் அப்படி யூஸ் பண்றாங்கன்னா திஸ் இஸ் த நார்மல். யூ ஷுட் பி வெரி ஃபெமிலியர் வித் வாட் இட் இஸ். when we pass an incident rays to a reflecting surface, அந்த பாயிண்ட் ஆஃப் கான்டாக்ட்ல இருந்து ஒரு பெர்பெண்டிகுலர் லைன் வரைஞ்சா தட் இஸ் செட் டு பி நார்மல். அந்த லைன் பேர் நார்மல். அண்ட் அது ரிஃப்ளெக்ட் ஆகுறது சேம் ஆங்கிள் ரிஃப்ளெக்ட் ஆகும். ஸோ லாஸ் ஆஃப் ரிஃப்ளெக்ஷன்ல ரெண்டு, த ஆங்கிள் ஆஃப் இன்சிடென்ஸ் அண்ட் ஆங்கிள் ஆஃப் ரிஃப்ராக்ஷன், இது ரெண்டுமே இந்த நார்மலை வச்சு இந்த ஆங்கிள் சொல்லுவோம், வில் பி ஈக்குவல். தட் இஸ் நம்பர் 2, செகண்ட் பிரின்சிபல், செகண்ட் லா ஆஃப் ரிஃப்ளெக்ஷன். ஓகே, அண்ட் வித்தவுட் வேஸ்டிங் டைம் வில் கெட் இன் டு ரீஃப்ராக்ஷன். ரீஃப்ராக்ஷன்னா என்னன்னு இப்பதான் ரிஃப்ளெக்ஷன் சொல்லும் போது பாரு. வென் a ray of light is passed, இங்க ஏர் இருக்கு, இங்க வாட்டர் இருக்கு, இங்க என்ன மீடியம் வேணா இருந்துட்டு போகுது. ஓகே, when a perfectly reflecting surface is present, ஒரு ray of light pass பண்ணும்போது it will be totally reflected. Okay, and when such medium is not present, அப்ப வந்து லைட் வந்து டோட்டலா ரிஃப்ளெக்ட் பண்ண முடியாத மாதிரி ஒரு மீடியம் இருக்கு அப்படின்னா some of the light will be refracted. It will go here, இந்த பக்கம் போகும். இதான் இன்சிடென்ட் லைட் அப்படின்னா it will be refracted. It will go from one medium to another. That is basic refraction. We'll study using this image. Here air, inge air, கீழ glass. Okay, incident ray of light pass பண்றோம், இங்க point of contact இருக்கு, அப்ப இங்க நார்மல் வரைவோம். This is normal. Okay, அப்போ when air and glass இருக்கும்போது glass is not a completely reflecting surface, so light enters it with this angle R, with this normal. So this angle is angle of refraction, and this is again anga paatha mari angle of incidence, rendume with respect to normal. So this is basic explanation of what is refraction. Okay, give me a minute. Very sorry. So we were studying about refraction. We know what is refraction now. Okay, and we have another two concepts which are related to refraction, which is critical angle and total internal reflection. Okay, see, when we say refraction, we know what is refraction. Air இங்க எடுத்துக்கிறோம், இங்க glass எடுத்துக்கிறோம். When we pass a light from glass, say, இங்க இருந்து ஒரு incident ray, இது ரெண்டுல எது denser mediumனா, air is less denser than glass. Density na, how much closely the molecules are packed. Okay, this is less rarer medium, more denser. This is denser medium. When we pass an incident ray from here, and we'll draw a normal here, okay, and it will be refracted like this, and this is angle of incidence and this is angle of refraction. Okay, இப்போ glass நம்மளுக்கு critical angle na என்ன அப்படின்னு தான் பார்க்கிறோம். Critical angle na என்னன்னா, whenever an angle of incidence is fixed such that இந்த refracted rays வந்து இந்த லைன்ல இருக்கணும், which will make 90 degree with the normal. So whenever the angle of incidence makes the refracted angle 90 degree, that is critical angle. Okay, and when a total internal reflection is a concept, என்னன்னா, same air, rarer medium, same glass, denser medium, we are passing a rays from here. Okay, we are drawing a normal, this is normal, this is incident angle. இந்த incident angle வந்து எப்போ critical angle ல வைக்கிறோமோ அப்போ refracted rays வந்து இங்க இருக்கும், அதாவது இப்படி இருக்கும், 90 டிகிரில இருக்கும். அத critical டிகிரிக்கு மேல, critical ஆங்கிளுக்கு மேல இந்த angle of incidence increase பண்ணும்போது it will totally reflect, it will come here as we increase this, it will finally after critical angle it will reflect totally. So by adjusting the angle of incidence more than the critical angle will make a light rays reflect to the same medium, and we can prevent it from refracting into another medium. So this is the basic concept of total internal reflection. Have all of you understood? If not, please let me know. Understood?
Yes, ma'am.
Yeah,
Yes,
okay. Okay, the application is basically fiber optic cables. See, perfect reflecting surface தான் எடுத்துக்கணும்னா mirror. It has its limitations in use. But when we can use any medium which is comfortable in various application, and when we have this concept of increasing the angle of incidence beyond the critical angle and having this property of reflection, we have various applications. One application is fiber optic cables. You know, telecommunication signals, those waves, இப்போ fiber optic cable na, it is basically a cable used for television transmission, you know, telephones, internet, அதுக்கெல்லாம் அந்த கேபிள் யூஸ் பண்ணுவாங்க. அதுல என்ன இருக்கும்னா அவுட்டர் லேயர் ஒன்னு கொடுத்திருப்பாங்க, உள்ள ஒரு கோர் லேயர் கொடுத்திருப்பாங்க. It is not using some electricity or anything, it is basically using this total internal reflection. They'll pass this wave, that communication wave we're using, the microwave, எந்த ஆங்கிள் பாஸ் பண்ணணுமோ அந்த ஆங்கிள் பாஸ் பண்ணுவாங்க, and it will be reflected because of the total internal reflection, because the angle of incidence will be more than the critical angle and it will be totally reflected. And அது எவ்வளவுக்கு எவ்வளவு ஃபாஸ்டா போகணுமோ அவ்வளவுக்கு அவ்வளவு இன்சிடென்ட் செட் பண்ணுவாங்க. And on a chain basis, on a continuous basis, total internal reflection will be happening, and the information with that particular communication wave will be transmitted. That is one application of total internal reflection. Okay, we'll go through certain previous year questions and we'll continue. We'll go into previous year questions. Please try to answer. Yes, it is option A. See, one trend is this instrument which is used for measurement. Please put note and write it down. These are PYQs. Only these trends are going to help you. Other concepts in physics, biology, and chemistry are going to understand it. Instruments used and the measured quantity measured. This is one repeated trend. And we cannot, it is very factual. Since it is very factual, we cannot dictate each and every instrument and what it is used to measure. Okay, so please make a list of those things and have it in your notes. Come to question 2. What is the working principle of hydrogen bomb? We'll go deep into it as we go into the concepts. Just try to answer it. What is the concept behind hydrogen bomb? Okay, at least narrow down options. Will it
Uncontrolled nuclear fusion.
see basically bomb அப்படி சொல்றாங்கன்னா it is not something எலக்ட்ரிசிட்டிக்கு யூஸ் பண்ற லேப்ல வச்சு யூஸ் பண்ற ஒரு நியூக்ளியர் ரியாக்டர்ல யூஸ் பண்ற ஒரு திங்கா இருக்காது. ஸோ narrowing down options நான் சொன்னது அன்கண்ட்ரோலுக்கு வந்துடணும். Okay, now tell me the answer. What did you just say?
Option D.
Yeah, it is option D. See, there is atom bomb, there is hydrogen bomb, and also there is a process called nuclear fission, and there is a process called nuclear fusion. See, fission is when two lighter unstable nuclei, bombards. It will release a lot of energy. Okay, that process is called fusion. Okay, and fission is when a larger atom, or ultimately the nucleus, which is very unstable, which has lots of internal energy, which is disturbing its balance. It's
Okay.
Yeah, please ask. Do you have any doubt? See, when it is fission, a larger nuclei gets split into smaller nuclei. Okay, that is fission. And fusion is when two lighter nuclei bombards to become one larger one. That is fusion. That is the basic difference. And both involves lot of energy will be released. Involves release of lot of energy. Okay, and when we have this capabilities now, facilities to control the process of nuclear fission, we still don't have the equipments. We are still not equipped to control fusion. No, fusion is still in experimentation phase to be controlled. Okay, so atom bomb basically works on the principle of nuclear fission, and hydrogen bomb works on the process of nuclear fusion. And what is the natural phenomena occurring in the sun, whether it is fission or fusion?
Fusion, ma'am.
Fusion, ma'am.
Very good, very good. It is fusion. Okay, and when it comes to bomb அப்படி சொல்லும்போது it is definitely uncontrolled. Okay, and also another difference between fission and fusion is that fission will be a chain reaction, whereas fusion is not a chain reaction. As well as fission will leave out many radioactive waste which should be dealt with. Okay, but fusion will be more cleaner than fission. So that's why experiments are going on to make a controlled nuclear fusion process for the process of electricity. Okay, in the nuclear fission layume எதுக்கு யூஸ் பண்றாங்கன்னா for the process of electricity only. That unstable uranium isotope will be unstable. அது ஸ்டேபிள் ஆகிறதுக்கு controlled environmentல விட்டோம்னா energy release ஆகும். That energy release we can use it to heat water, or we can use that energy to produce electricity in any way. That is the basic idea behind it. Okay, we'll come to question 3. What is the answer?
Leukemia, ma'am.
Option.
Yes, very good. It is leukemia. It is WBC when it is high, when it is excess, leukemia will be the disease. Okay. I gave the assignment regarding vitamins, right? What is the answer? Rickets. Basic question.
Vitamin D, ma'am.
Vitamin D.
Vitamin D it is. Okay. இந்த vitamins எல்லாம் என்னன்னு சொல்லுவோம்? Fat soluble water soluble ADENK. ADEC.
Fat soluble, ma'am.
Yes, it is fat soluble. And other vitamins are just B and C. B complexes like B12, B2. Those vitamins and C, they are water soluble. Okay, that is the only types we have, fat soluble and water soluble when it comes to vitamins. Okay. Question 5. Instrument hydrometer.
Option A, ma'am.
Okay. What is specific gravity? It is option A. See, specific gravity is also relative density. Make a note. This is previous year question we are discussing. Make a note. See, when specific gravity or relative density is the density of an object, any object it can be, divided by density of the water. Okay, this is specific gravity or relative density. என்னன்னா ஒரு water எடுத்துக்கலாம். For example, A and B, water, it is filled with water, and we have a steel ball and we have a wooden ball. In the same volume as that of water. Wood floats and steel sinks. Okay. When the specific gravity is greater than 1, it sinks. When the specific gravity is less than 1, it floats. Simply. This is specific gravity or relative density. Why it sinks or why it floats. Okay, come to question number 6. Nautical mile is a unit of. What is the answer?
C, ma'am.
Length.
Yes, it is C. See, nautical mile with a distance தான் measure பண்ணுவோம். Length is nothing but distance. எங்க especially use பண்ணுவோம்னா when we are talking about from a nation's boundary towards a certain point in ocean or sea. அப்ப nautical miles use பண்ணுவோம். So airplane or ships அதுல அங்கெல்லாம் வந்து இவ்ளோ nautical miles அவ்ளோ nautical miles, that will be the unit used in common. Okay, come to question number 8. Vitamin responsible for blood clotting. It is a very repeated question.
Vitamin K.
What is that? Yeah, very good. It is vitamin K. It works on stopping the blood. Okay, it helps in formation of blood clots. Vitamin K, as well as deficiency of vitamin K will when a person is bleeding from an injury, if vitamin K is in a very lesser level, the blood will not clot. There will be profuse bleeding. Okay, so vitamin K is the answer. And question 9. Speed of wind is measured by. What is the answer?
Anemometer.
Very good. Make sure you go through, what is speedometer, spectrometer, hydrometer, what it is அப்படின்னு சொல்லிட்டு make a note of it. Question 10. Father of antibiotics.
Louis Pasteur.
No, man.
Alexander Fleming.
No.
Antibiotics. Sorry, ma'am.
Alexander Fleming வந்து இங்க வரவே மாட்டார் actually. It is Selman Abraham Waxman. Just remember with some, they are asking you these kind of factual questions. Who is the father of this and who discovered this, who invented that? இந்த மாதிரி factual questions வருது அப்படின்னா you have to make sure you have some process of memorizing this. Antibiotics அப்படின்னா Waxman, Selman Waxman அப்படின்னா you can have logic இல்லாத methods to remember such things. There is two man coming in the name, and make sure you have certain code words or things to remember antibiotic. So you have to have some memory strategy to it. You can even இந்த மாதிரி எதுவும் ரபிஷா பண்ண வேணாம் அப்படின்னா கூட you can go search Selman Abraham Waxman and how he discovered antibiotic. If you love reading, you can go and read a little bit history, and it will just stay in your mind forever. Just do one of those things which works for you. And you have to make a list of things which I'll be giving you. Okay, certain topics like antibiotics, radioactivity. I'll be providing you with certain topics at the end of this general science class. And I want you to go and find out who discovered that particular thing. Who is the father of that particular thing. Make a list and revise it before exam. Okay, you have to do that and use your own memory methods. Come to question 11. Animals active at night are called. What is the answer? See, animals active at night are called nocturnal animals. And diurnal animals are animals more active in day. Animals which are more active like day, they'll be active in night. So more active in night is nocturnal. Parasites are some animals which will feed on another living organism or animal. That is parasites. I think we all know that. Noctodiurnal is animals which are, which has this capability. They'll switch between day and night. That is noctodiurnal, combination of A and B. Question number 12. What is the answer?
A, ma'am.
Okay. See, very good. Lines joining places of equal temperature is solrangana. There is, Earth, North America, South America, Europe, Africa, India, Australia. See, there is இதுவே எடுத்துக்கலாம் வேர்ல்டே எடுத்துக்கலாம் ஓகே ஐசோதெர்ம்ஸ்னா மேப்பிங் த ஹோல் வேர்ல்ட் ஆர் அ சர்டன் பர்டிகுலர் ரீஜன் இங்கெல்லாம் டெம்பரேச்சர் ஈக்குவலா இருக்கு இப்படி ஒரு லைன் ஃபார் ரெக்கார்டிங் த ரீஜன் வித் ஈக்குவல் டெம்பரேச்சர் இதெல்லாம் வந்து டெம்பரேச்சர் பேசிஸ்ல பண்ணா தட் இஸ் ஐசோதெர்ம். ஐசோபார் இஸ் ப்ரெஷர் பேசிஸ்ல பண்ணா இந்த இடம்லாம் வந்துட்டு கரெக்டா ப்ரெஷர் வந்து ஆல்மோஸ்ட் நியரா இருக்கு அப்படின்னு மேப் பண்ணுவாங்க. ஸோ தட் இஸ் based on pressure na it is isobars, and based on rainfall that is isoheat. Isomers is not one of these. It comes in chemistry. Okay, it is something else. Come to question 13. Natural radioactivity was first discovered by
Henry Becquerel.
Very good. It was discovered by this person, but named அப்படி கேட்டாங்கன்னா it is Marie Curie. Okay, come to question 14. Use root word kind of stuff. What is the answer?
Psychology.
It is cytology. And go and note down what is entomology, what is homoplastic, what is hormonology. Hormonology pathale theriyudhu, it relates, it is study of hormones and its functions. Okay, and go and read on entomology and homoplastic. And there was a separate question on homoplastic in another previous year. Okay, question 15. When a body is accelerated, நம்ம இந்த கான்செப்ட்ஸ் எல்லாமே படிச்சோம். acceleration concept. Please apply whatever we read now. What is the answer?
Option B.
Option
B.
B. Yeah.
Speed will always change.
See, okay, I'll again tell what it is. Acceleration அப்படி சொன்னா rate of change of velocity தானே படிச்சோம். And velocity அப்படின்னா there is speed as well as direction. So these two things will be here. So speed வந்து ஒன்னு சேஞ்ச் ஆகலாம், இன்க்ரீஸ் ஆகலாம், இல்ல டிக்ரீஸ் ஆகலாம், இல்ல டைரக்ஷன் சேஞ்ச் ஆகலாம். When these things happen, acceleration will change. Okay. When speed increases, positive acceleration. Speed decreases, negative acceleration. Okay. If speed change ஆகாம direction மட்டும் change ஆனாலும் there is change in acceleration. So speed will always change னு சொல்ல முடியாது. Understood?
Okay.
Okay. See, velocity never changes னு சொல்லிருக்காங்க. First இந்த option eliminate பண்ணலாம். ஏன்னா velocity, change in velocity is acceleration. Okay. Velocity has to change in order for acceleration to occur. And speed will always change. டைரக்ஷனா கூட இருக்கலாமே. டைரக்ஷன் சேஞ்ச் ஆயிருக்கலாம். ஸ்பீட் அப்படியே மெயின்டைன் ஆயிட்டு. அப்பவுமே ஆக்சிலரேட்டட் தான் சொல்லுவோம். டைரக்ஷன் ஆல்வேஸ் சேஞ்சஸ் சொல்லியிருக்காங்க. ஈவன் டைரக்ஷன் ஆல்வேஸ்னு இல்ல. டைரக்ஷன் இல்லாம ஸ்பீட் சேஞ்ச் ஆனாலும் இட் இஸ் ஆக்சிலரேஷன். ஸோ நாட் ஆல்வேஸ். இட் இஸ் ஆக்சுவலி ஸ்பீட் மே ஆர் மே நாட் சேஞ்ச். ஆர் ஈவன் டிரெக்ஷன் மே ஆர் மே நாட் சேஞ்ச் கொடுத்திருந்தாலும் அந்த ஆப்ஷன் மட்டும் தான் கரெக்டா இருக்குன்னா that will be the correct option. I think we are more clear about velocity and acceleration here. Come to question 16. Which of the following is not a unit of energy? Just try.
electron volt, ma'am.
இப்படி represent பண்ணுவோம். Electrons energy present with the electron. So it is also energy. So these three things can be used as a unit of energy, but what is a unit of power? Make a note of it. We missed it there. Come to this question. Which is the longest bone in the human body? What is the answer?
Option D, ma'am.
Femur,
Yes.
ma'am.
Femur is the thigh bone. That is the longest bone. We will fibula, radius, and stapes. Stapes is a bone which is present in the middle ear. காதுல middle earல இருக்கிற bone is stapes. Okay, fibula is a bone which is in below knee. It is present below knee. And radius is a bone which is present under our forearm in the hands. And I'll show you the skeleton. See, this is radius. This bone in your arm below your forearm, this is radius. And this is fibula below your knee. Okay, you just download an image like this which has basics of where is fibula. There will be two bones here. You can see it here. No, there is two bones. The white la kudukkadu, red la kudukkadu. This is fibula, and here there will be tibia, and this thigh bone will be femur. Okay, ingyo rendu bone irukku appadi thigh-liyo, and one is radius, one is ulna. Okay, and sternum na chest la irukano, humerus inga irukano, pelvis. Please know the basic terms used with respect to skeleton. And coming back to question number 18. What is the answer?
B, ma'am.
It is basically, the answer is C. See, I have a doubt with this question. I'll come to this question later. Okay. Question 19. What is the answer?
C, ma'am.
See, it is C. And microvilli and plasmole or something which is present only with respect to animal cells, not with respect to plant cells. Go and search for the functions it does. And plasmodesmata na enna nariya cells irukum. Cells la link aayirukkum. Appadhaan tissues form agum. Tissues together will form an organ, and organ will together form an organ system. That is how any organism works. So idella cell ஒரு cell nu vechukonga. Everything will be joined together. Appa they'll have certain connecting way between each. Okay, and that is called plasmodesmata. And plasma lemma na enna cell membrane plasma lemma da. Plasma membrane or cell membrane or plasma lemma, all are same. Come to question 20. And with this question I want you to tell endocrine glands is very important for your science part of the syllabus. Endocrine gland will involve lot of things. Nervous system like pituitary gland, pineal gland, thyroid, all those glands which secretes hormones will come under endocrine glands. I want you all as a homework, please go through what are the glands which is involved with endocrine and what are the hormones each of those glands produces and what is the use of those hormones. Please go through it and come before next class. Okay. Come to question 20. Vertebrates have two endocrine glands associated with the brain, namely it is pituitary and pineal. With the brain associate ஆயிருக்கும். Even with respect to digestive tract, pancreas associate ஆயிருக்கும். Endocrine glands is a whole a lot. Okay. With respect to brain, it is pituitary and pineal. Question 21, a repeated question as I said. To prevent prolonged bleeding. What is the answer?
B, ma'am.
Yeah, ma'am.
Vitamin K.